Hello everyone, welcome back to my Additional Max and Max channel. For your information, this is the most favorite topic for every student, I guess. So this is also very important topic for Form 5 Additional Max students because this is actually under linear programming under KBSM. And for Form 4 student, this is actually under KSSM syllabus. And at the same time, this topic is also under Additional Max KSSM. So in short, this topic is very important as it's actually involving hot question because it is actually solving problems in our daily life. So in order to master the max and additional max, you must focus to this topic and ensure that you are actually can score perfectly for this topic. So that is why I am sharing with you the most impressive video to solve the linear programming or linear inequalities problem. I'll be sharing two videos. This is my first video, alright, and the next video I will upload as I free. So please enjoy the video teaching conducted by US teacher. Have fun.
Here, in a high school winter formal, male students are charged $20 per person, and female students are charged $15 per person. The Student Association makes sure that the ratio between male and female is at most 1 to 3. Also, it is told by the school that the school hall can fit no more than 100 people. If the Student Association wants to maximize their profit, how many male and female students should there be in the winter formal? Now, our goal is to maximize the profit. So whenever we're maximizing, we are talking about linear programming, or in other words, optimization, right? So the goal is maximize the profit. So how can we find the profit? Well, here, we know how much we're charging per person for males and female students, right? However, we don't know how many students are attending the winter formal. So start off, we have to write the let statement. So if we say let M equals to the number of male students, and we let F equals to the number of female students, all right? So whenever we're doing word problems, first thing we have to do is to set up the let statement. Tell your teachers what those variables stand for. Okay, so here we have the M, which stands for male students, F, which stands for the female students. Okay, so maximizing the profit, how can we find the profit? Well, the main function, we usually denote it with a Z. Okay, profit, it's found by the amounts per person times the number of people. Okay, so for male, how much are we charging? Male students is 20 per person, right? So we have 20 per person, and we have M amount of people, right? So we have 20 times M. What about for female? Female, we're charging $15 per person. So we have 15 per person. And how many females are attending? We have F amount of females. So we have 15 times F. Now the total profit will be just adding them up. Okay. All right, so now we have the main function being set up, which is 20M plus 15F. Remember, in all linear programming or optimization problems, there are some constraints, right? So let's find the constraints now. First constraint we have here is here. The student association makes sure that the ratio between the male and female is at most 1 to 3. So the ratio between male to female, is at most 1 to 3. At most, right? So it's no more than. So this is the equation being set up. However, we can make it look nicer by cross multiplying. So throw the 3 to the m and throw the f's to the 1. So we have 3 times m, which is 3m, is less than or equal to f times 1, which is just f. Okay, so this is one of the constraints. Now, to save more space, let's write it on the side over here. By the way, before we even make any changes, we can actually move everything to one side. So subtract f on both sides, we get 3m minus f less than or equal to 0. Now the reason we want to do that is because when we come to the graphing parts, we can just treat it as if it was 3m minus f equals 0. That is much easier to graph, right? Okay, so we have one constraint here. Let's see if there are any more constraints. Now, also here, it is told by the school that the school hall can fit no more than 100 people in total, right? So how many people do we have in total? We have m number of male students, we have f number of female students. So in total, which is m plus f, it's no more than 100. Okay, so that means it is less than or equal to 100. Okay, so these two, in this case, these two in blue, will be our constraints. Now that we have the constraints, let's try to graph them out separately and solve for the answer, okay? So, start off, we have 3m minus f, 3m minus f, less than or equal to 0. So to graph it, let's treat it as if it was equal to 0 first, okay? So now, let's say this horizontal line is our m, which stands for male, and the vertical line stands for female, okay? So, first off, when m is equal to 0, m is equal to 0, okay? So we have 3 times 0 minus f equal to 0. 3 times 0 is 0, so we'll have 0 minus f equal to 0. That means our f must also equal to 0. So when m is 0, f is also 0. That means this, it's one of the points on the graph, okay? Next, how many points do we need to make a straight line? We only need 2, right? We have 1 already. Let's find one more. Okay, so now let's try 30. If m is equal to 30, 3 times 30 minus f equals 0. So 3 times 30 is 90, right? 90 minus f is equal to 0. So f will be 90 as well, because 90 minus 90 equals 0, right? Having said that, when m is equal to 30, which is here, our f will equal to 90. 90 is right here. So they will intersect at this point over here, okay? Now we have 2 points. Let's connect them and make our line. So that is our straight line for 3m minus f less than or equal to 0. Now, here we have to figure out less than or equal to 0. Which side are we talking about? Now, if we try to plug in test values, we will know that it's talking about everything on this side, okay? Everything to this side. Now, we've done that before, so I'm not going to waste time plugging in test values for you. Okay, now moving on to the second constraint, m plus f less than or equal to 100. Now again, we will write it as m plus f equals 100. Okay, so for this one, it's easiest when we just plug in zeros. Okay, so if m is equal to 0, we have 0 plus f equals 100. So our f will equal to 100. Okay, so m equals 0, f will equal to 100. So that is 1 point. Now, similarly, instead of letting m equal 0, let's let f equal to 0. So f equals 0, we have m plus 0 equals 100. So m, in this case, must be 100, right? So f is 0, m would be 100. So that is the other point on the graph. Having 2 points, we just connect them and we get our straight line. Okay? Now, this is the line for m plus f less than or equal to 100, right? Now again, we have to figure out which region we're talking about. Put in test values, we know that we're talking about everything below this line. Okay, so now we have to think, which is the region that falls under the green line and to the left of the purple line? Well, that's easy. That would just be this region over here. Okay? Now, how many corners? So we know that this is the possible region, the feasible region, right? Remember, for optimization, we only need to look at the corners. So we have a corner here, we have a corner here, and we have a corner here. Now, you might ask, what is the coordinate of this corner? We don't actually know what it is, right? There is actually an easy way to find it, and that is to equate these two equations together. Okay, so here we have 3m minus f equals 0. And here we have m plus f less than or equal to 100. So that is equal to m plus f minus 100 equal to 0, right? So now equate them, we have, equate them, we'll solve the answer. So, or, another way of doing so is to plug into the calculator. So if we plug into the graphing calculator, these are the lines we're given, and we're now looking at this part of the graph, right? So we have three zeros, corners. 1 corner, 2 corner, 3 corners. And this corner has the coordinate 25, 75. Okay? So remember, once we have located these corners, we just plug in back into our original function, which in this case is 20m plus 15f. Okay? 20m plus 15f. So before we forget, z is equal to 20m plus 15f. Alright? So now, these are the 3 coordinates we've written down from the graph. Okay? 0, 100, 25, 75, and 0, 0. So now, these are the numbers. We're just plugging into the equation over here. Starting off with this one. This is our m, and this is our f, right? So our equation will be 20 times 0 plus 15 times 100. So 20 times 0, 0. 15 times 100 is 1500. Okay? Next, 25 and 75. So we have 20 times 25 plus 15 times 75. So what do we get? 20 times 25 is 500 plus 15 times 75 gives us 1125. And you add them up, you will get 1625. Last but not least, 0, 0. That should be easy, right? 20 times 0 plus 15 times 0. 0 times 20, 0. 0 times 15, 0 as well. So this will give us 0. So all in all, now compare these 3 numbers. Which one is the maximum? Well, obviously, we have a winner. 1625 is our winner, right? This is our maximum. And why are we finding the maximum? Because we are maximizing the profit. Okay? So all in all, how many male and female students should there be if we were to maximize the profit? Now that goes to here. 25 is our M, 75 is our F, right? So that means we need to have 25 males and we need 75 females in total in order to maximize the profit. Okay? A toy factory produces dolls and robots. The factory indicates that an expected demand of at least 90 dolls and 70 robots each day. Due to a shortage of raw materials, no more than 100 dolls and 155 robots can be produced daily. However, in order to honor the contract, at least 200 toys must be produced each day. If each doll sold results in a $2 loss, while each robot will generate a $4 profit, how many of each type should be produced daily in order to maximize profit? Now, again, we want to maximize profit. So we're talking about linear programming or optimization, right? So maximizing profit, first off, we know how much we're earning or losing per piece, right? However, we don't know how many pieces we're producing. So first off, write out the less statement. So we let, how many items are we talking about? We're talking about dolls and robots, 2 items. So let's say let D be the dolls and robots is R, right? So we R be the robots. Okay, so tell your teachers what these variables stand for. So now we have these variables. What is their profit? Our profit, the main function denoted in Z, that would be for each doll, okay? Each doll is a $2 loss, right? So when we're talking about loss, we will have -2. Lose $2 per doll, and we have D amount of dolls, so we have -2D. Okay? Next, for robots, each robot generates $4 profit. So we have +4, it generates profit, right? That's for one robot. So we have R amount of robots, so we have +4 times R. 4 times R, it's the total profits for robots. And you add them up, you get the total profit, okay? So you see, the robots generate a profit, while as the dolls will produce a loss. So we have to balance it out and see how we can maximize the profit, okay? Now we have the main function. Let's think about the constraints. Now the constraints here are a bit tricky. Here, first, we know that the expected demand is at least 90 and 70 for the dolls and robots, okay? Next, due to the shortage of materials, no more than 100 dolls and 155 robots are to be produced. So what does it mean? Let's say we have dolls, we have robots, okay? First off, demand is at least 90 dolls. So dolls must be at least 90, right? Robots, at least 70. These are the minimums they need to produce. However, due to a shortage of raw materials, no more than 160 dolls. So no more than 160 dolls. And no more than 155 robots are to be produced. So these two equations are set up by combining these two sentences together. Usually in word problems, one sentence corresponds to one information, right? However, for this, you have to combine two sentences together to create our constraints. Okay? Next, we have one more constraint actually. In order to honor the contract, at least 200 toys in total must be produced. So, we have D amounts of dolls and R amounts of robots. Together, that means we're adding them up, right? So D plus R, together, we have to have at least 200. So at least that means greater than or equal to 200. Okay? So these will be our constraints. Okay? Now, once you have the constraints, again, you just throw it on the graph, see how it looks like, check which region are we talking about, and then find the corners. So, since it's just plugging in numbers, and in this case, it's really easy because D and R, you have a graph. We don't consider the negatives, right? So we have a graph. If this is D, that is R, right? If D is in between 90 and 160, that will be just two straight lines over here. Okay, and it's in between here. Now, next we have R in between 70 and 155. So we have 70 and 155. So we're talking about this square inside. Okay, so that's how easy it is. And after that, you just plug in another line and see where it covers. Okay, so not going to waste time on this, but plugging into a graphing calculator, you will have this graph over here. Okay, and this time we are looking at this region. Okay, because we are looking at D plus R is greater than 200. So our graph, the pink line, is x plus y equals 200. Okay, if it's greater than 200, we're looking at above, right? However, it stays inside this square, but above the pink line. So we're only looking at this part, but not this. Okay, so now in this region, we have 1, 2, 3, 4, 5 corners. Okay, 5 corners, and the graphing calculator can already tell you what the coordinates are for each corner. Okay, so now we take a look at these corners, plugging into our main function, which is negative 2d plus 4r. Okay, negative 2d plus 4r. Negative 2d plus 4r. Okay, and that would be our z function. So plugging in one by one, what do we get? First off, 90 and 155. We have 90 is d, by the way, and that will be r. So we have 90 times, we have negative 2, negative 2d, right? So we have negative 2 times 90 plus 4 times 155, and that would give us 440. Right? Next, negative 2 times 160 plus 4 times 155, and that will equal to 300. Moving on, negative 2 times 160 plus 4 times 70. That will give us negative 40. So you see this one, you're actually losing money for producing this much. Okay, so this is no good for sure. Next, negative 2 times 130 plus 4 times 70. And that will equal to 20. Last but not least, negative 2 times 90 plus 4 times 110, and that will equal to 260. Okay, so now make sure, don't forget our goal. Our goal is to maximize the profits, right? So these are all the profits. Which one is the maximum over here? Well, obviously 440 is the maximum, right? So if we want to maximize the profit, in this case, this is maximizing the profit. We will have to produce 90 dolls and 155 robots. Okay, so the overall answer is 90 dolls and 155 robots in order to maximize the profit. And if you produce this much, the profit will be $440.
Yes, $440. Thank you so much, sir, for your impressive teaching method. Till then, I shall see you all in my next video teaching. Bye bye and have a nice day.